Afternoon, peeps. Well, here's something else we think they could have thought about a little bit more. Okay? Spoke about this the other day, but I've been thinking about it a bit more. The moon, us, curvature. Gravity is a curvature of space-time. I don't think it is. If it was, the moon would have, or would be, coming a little bit closer all the time. Is it not going further away? It is. And something else about that. Isn't the moon tidally locked to planet Earth? Well, if it's tidally locked to planet Earth, that means there has been a constant force on it, pulling on it from all sides. Everywhere it goes, the same force is pulling on it to the extent that it's going around whatever it was doing. All the planets that are tidally locked, they eventually lock because the big mass is pulling at them from all directions the same, but pulling at them. So eventually the spin just stops because it's just goes on for billions of years probably, right? Don't quote me on that. But if it was a curvature of space-time, right, it would just roll, wouldn't it? There would be nothing to stop it. There would be nothing to stop the planets, the moons, being tidally locked to their respective planets, would there? If it was just the curvature of space and time, this is a planet, right? They say they've got this whole curvature, right, that comes out everywhere. So it's the same everywhere, right? That's in front and that's at the back. So the gravity, they say, is this curvature, and it catches the planet and it stays in the curvature. So this is looking down on it. So this is like the planet in question, and then you're looking down, and those are just the big hill it creates, right? So the moon is now moving away from us, isn't it? 3 point something centimeters, 1 point something inches a year. Now, if it was a curvature of space and time, the fact that it's only moving away by that much every year, are we now to suggest that it's just gotten to the furthest and now it's going to swing back and come back inside because it's caught in the curvature in space-time? Gravity is probably mass attracting mass from all directions, from all directions equally. It doesn't matter, does it? Give or take a few Ks if there's some kind of, I don't know, different mix of minerals and chemicals and substances on one side. It might have a slight bigger, stronger gravitational pull. But the moon, it collided many years ago and it ended up in an elliptical orbit, and now it's tidally locked, which means only one face faces us. So that face has obviously been pulled in, because if it was spinning, and it just keeps getting pulled in, and it stops. And that is why the same face faces us all the time as it goes around the planet, tidally locked. That wouldn't happen if it was just a hill. It would just keep rolling, wouldn't it? It would just keep spinning. So 2 reasons, right? 1, it's still moving away from us at that much every year. And 2, it's tidally locked. It isn't logical to think that a moon would tidally lock itself with its planet if it was a curvature, if it was like going round like that, it would just keep spinning. Is it not common sense again? Right, that's my afternoon rant out of the way. Like peeps.